Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So the topic that we are going to discuss today it is from the chapter number 4, that is Introduction to the Group 3A and 4A elements. So let's have a look at what does mean by the Group 3A and 4A elements and what are their main properties as well. When we have a look on the periodic table, we just see that the periodic table has been divided into different groups as well as into different periods. Mainly, there are 7 periods in the periodic table. On the other hand, when we have a look, these are the vertical columns showing the different groups in the periodic table. So, groups have been divided into two categories, A and B. So, there are two blocks in the periodic table, the group A elements and the group B elements. So, today we will discuss about the group 3A and group 4A elements in the periodic table, that is over there. It's group 3 and it's group 4. So we will study about these two groups separately. One thing that you have to keep in mind here, we have the purple color in which the group 3 and 4 elements are showing. All these are mainly known as metalloids, and the elements that are aluminium, gallium, indium, this lead, bismuth, all these are showing their color in the blue one. So they have both the properties of metals and non-metals, and these are basically some non-metals in the periodic table. So over there we have lanthanide series and actinide series. These are known as the outer transition elements, and these elements are known as inner transition elements. Transition elements are the elements that have the involvement of d orbitals as their valence shell, and the electrons can move out from their d orbitals or can transit between different oxidation state. So the transition elements have different oxidation state, more than one state. So let's have a look on the group 3 elements. Here the first one element of the group 3 element, we have boron. As its atomic number is 5, its electronic configuration that we can write like 2 electrons in the first shell and 3 electrons in the valence shell. So we can also write it as 1s2, 2s2, and 2p1. So this is its valence shell. On the other hand, the next element is aluminium. Its atomic number is 13. So it is having total 13 electrons, 2 in the first shell, 8 in the second shell, and 3 in the last shell. The third one element is gallium. Its atomic number is 31. Its electronic configuration, we can also write it as 1s2, 2s2, 2p6, 3s2, 3p6. First shell, this is the second shell, this is the third shell. On the other hand, here we have then 4s2. This is it's the outermost shell of the group 4A, and it also contain 3 electrons in the valence shell. So we can also write it as it's 1s2, 2s2, and next we have its d orbitals. This one is 3d, 1. So this is its valence shell electronic configuration. Then we have indium. Its atomic number is 19, and electronic configuration we can write it as 2 electrons, 8, 18, 18, and the last one shell again is having 3 electrons. Then we have thallium. Its atomic number is 18. Electronic configuration is of like this: K shell, L, M, N, O, and P. So this is its electronic configuration from the valence shells. So you guys can see that as they are group 3A elements, so all contain 3 electrons in their valence shell. So that's why their valence shell electron or valence shell electronic configuration just shows their group number, that what is their group number in actual. So we can identify the group number of any element from its electronic configuration easily, and it is also related to their different properties. Like we can say that it is related to their chemical properties, as well as also related to their physical properties. So this is very important to know about the electronic configuration of any element, as we are just having their group 3 elements. So if we know their electronic configuration, especially from their valence shell, that how many electrons in their valence shell, so we can identify that what type of bond that element will made with the other, what is its valency, and what is its main chemical properties. Next, let's have a look on the group 4 elements. So here we have group 4 elements. First one element here we have carbon. Its atomic number is 6. Electronic configuration we can write it as 1s2, 2s2, 2p2. So this is its valence shell. Next element we have silicon. Its atomic number is 14. Its electronic configuration 1s2, 2s2, 2p6, 3s2, and 3p2. So this is its valence shell having 4 electrons. Then we have germanium. Its electronic configuration valence shell is 4s2, 4p2. Then we have tin. Its symbol is Sn. Atomic number is 50. Its valence shell is 5s2 and 5p2. Then we have lead. Its symbol is Pb. Atomic number is 82 and its electronic configuration of the valence shell is 6s2, 6p2. So here you can see that the first one element is having 2s2, 2p2, then we have 3, 4, 5 and 6. So here the number that we have 2, 3, 4, 5 and 6. All these are their specifically pair number, and then we have their number of electrons over there as their power. So these are showing mainly their group number. So you can see that all have 4 electrons in their valence shell, so their group number is 4a. That is related to their some chemical properties. On the other hand, when we have a comparison of both the elements like group 3a and group 4a elements. So when we move from left to right, their properties as ionization energy increases. Then the second property we have electron affinity. It also increases when we move from left to right in the periodic table. And then we have their electronegativity. It also increases when we move from left to right in the periods in the periodic table. So this is the main some calculations that have been done according to their behavior, how many electrons in their valence shell, can they lose the electrons easily or can they gain the electrons easily. On the other hand, the second possibility we have, can they share the electrons easily. So all that depends upon their number of electrons, that electrons present in their valence shell. So how many electrons present in their valence shell, it depends upon their bonding with the other elements. On the other hand, we have here carbon. It is specifically a non-metal. Then we have silicon. Both the carbon and silicon have almost same properties. Then we have germanium. It is mainly we can use it as a simple metalloid that is having both the properties of metal plus non-metal. Then we have tin and lead. They also have the same properties like metalloids. So this was all about today's lecture of group 3 and group 4a elements. I hope you guys understand, and if you have any queries you may ask me about that in the comment section and I will get back to you guys soon. And the next topic that we will discuss, it is the occurrence of aluminium and boron. So we will take the element from group 3a. So we will study about their occurrence, that how they are found in the form of different compounds. For that time, you guys have a good day and keep learning.